In this video, we're going to go over how to do the analysis, a subsample analysis in Rstudio. Specifically, we're going to be talking about our car mileage example that we talked about in our lesson 8 videos. In this video, we'll talk about the incorrect way to do the subsampling, we'll talk about the correct way to do subsampling, and then we'll talk about the average of the subsample, doing the analysis of the average of the subsamples. So again, in this example, we're trying to see if there's a difference between the brands of car in terms of gas mileage. So let's get started. Always make sure you're in the correct directory. We're going to load our data, turn our variables of brand and car into factors. Now let's talk about the incorrect way to do the analysis first. The incorrect way would to just have your mileage, our response, and then just put brand. What this is going to do is it's telling R that we have 30 experimental units rather than 10 experimental units with 3 subsamples. So we can look at this ANOVA table, and this is definitely incorrect. It's not accounting for it, a fact that we only have 10 experimental units with 3 subsamples. What this is telling R is that we have 30 experimental units, which isn't how we designed our study. The correct way is to come down here and run this line of code, where we're now treating and getting an error term. We're producing the random effect error. What the result's going to look like is this. In R, you guys can also Google and research this. There wasn't a clear-cut way on how to do subsampling in R analysis, which is very sad in my book. So this was the one way that I could find it where our results will match, jump, and everything will be handy-dandy. And so what we're going to get is here's our brand. We're going to have 4 degrees of freedom, our sums of squares. Then we're going to have our 2 error terms here. This is going to represent our MSEE, or our experimental error sums of squares, and MSEE. Down here, the error within is going to demonstrate our degrees of freedom, our sums of squares, and our MSOE. This isn't as clean as what you would get in JUMP, but we're going to work with what we have and still get our answers. So you can notice that you don't have an F value or a P value. So from our notes, we can recall that our F value is going to be our MST, so 33.31, divided by our MSEE, which is 1.361. I'm going to save this as fstat. Now to get the p-value, we're going to go to our F distribution. We're going to look at our fstat. Then we need to input our degrees of freedom. Our degrees of freedom for the numerator is 4, coming from right here. So 4. Our degrees of freedom for the denominator is 5, coming from right here. And then we want the lower tail to be false. We can run this, and we'll notice that we'll get the same p-value as our JUMP users. Just so you guys believe me, if we scroll down here to our ANOVA table for our results, 0.0018, close enough if you round, as our p-value. So that's what you guys are going to have to do in your homework is, here's our treatment, then it's our treatment divided by our car. You could also, let me just put this note, one way is you might go car brand, and what this is going to give you is something that looks like this. But this F and this P value are not correct because here, what this is doing is it's taking this MST and dividing it by this MSEE, but this is not the correct way. So the best way to do this would to be brand divided by car. We get our treatment row, our row with the experimental error, and then our row with the observational error. Calculate your F, run your p-value. Okay, where again, this value is coming from your MST, this value is coming from your MSEE, this 4 is related to your numerator, this 5 is related to your degrees of freedom. All found here, boom. Now if we were to do the same thing, not the same thing, let's say we averaged over our subsamples and we did our analysis, we're going to read in that file, convert to factors. In this case, when we average over our subsamples, we can then just do a typical CRD, and we can see that our value here matches our F-stat and our p-value. Okay? Slightly off because they're rounding here. If we were to round, we'd be good. But and then we can do a 2 keys summary. Boom. In our lesson 8D video, I did a missing data analysis in JUMP. Here's doing the same thing, so I'm loading the cars data into a new variable called missing so that I can remove observation 1 and 4. I run the subsampling analysis, I calculate my F-stat. Let's just do this. Boom, boom. Be careful not to keep rerunning this or else it will keep taking off points. We're going to run this and we're going to get our summary. We're going to have our, I inputted the F-stat wrong. So our F-stat is going to be our MST, put in the wrong number, divided by our MSEE. We're going to get an F-stat, and then we're going to take that F-stat, and we're going to get the p-value. Again, this 4 is coming from here, the 5 is coming from here. Boom. And so our p-value is really low. Again, if we looked at our JUMP result all the way at the, I didn't put those answers in there. Forgot about that. But this will match our JUMP. And then if we were to average over the missing stuff, we'll notice that this result and our F-stat are not the same. With that, you should be able to rock out your homework.